Today we're going to learn about concave mirrors. We are going to go through pages 1 and 2 in your notes, and then I'm going to get you started on page 3, which will be your homework. Alright, the first kind of page are definitions to help you understand some of the stuff. It won't make a ton of sense until we actually start drawing out some diagrams, and then it'll make more sense to you. So, starting here, light travels in a straight line until it strikes the surface of the object. It is either then reflected, bounces off, absorbed, like when you're wearing a black shirt on a hot day, it absorbs that light, or transmitted through, which is like glass, lets the light go through. We are going to deal this week with things that reflect. When light changes direction by bouncing off an object, you have a reflection. An object with a reflective surface is called a mirror. We are going to look at the types of mirrors that are curved, and concave and convex will be the name of the two. When we draw an object, so let's say I'm standing looking in a mirror. I'm not going to try to draw a person. You all know how good I am at drawing. So everything that we draw is just going to take the shape of an arrow. So we'll draw objects looking in the mirror like this. For our mirror diagrams, this is how it is going to get set up. So I will have a dotted line through the center of the mirror. This is called the principal axis, and I will dash it like that for you. I'll always get that set up kind of in the middle of your space. From there, I will make a mirror. We're going to find out over the next couple days. It will be shaped, it'll be curved, either like this or like that. One side of a mirror has the reflective surface, the other side of the mirror has nothing, kind of like this. We have one side of the mirror is an actual mirror, but the other side does not have a mirrored surface. It will always be set up so that the mirrored surface is towards the left side of your sheet. Okay, and then from there, we will draw the object looking into the mirror as an arrow, always on the left side. And then finally, every mirror, because of the shape of it, the curve of it, it always, when the light hits it, makes it bounce off through a certain point. That point is going to be called the focal point or the focal length. We always will have that drawn. It'll depend on which type of mirror you have. It'll either be on the left side if it's concave on the front of the mirror, or it'll be behind the mirror for convex tomorrow, because those are curved in the opposite direction. Alright, continuing on for some of our vocab terms, and like I said, if it doesn't make sense right away, it eventually will. The first piece, the F, the point where all the light rays focus, it's where light hits a mirror. Because of the curve, it bounces off at an angle, and the bounce off always goes through one point, and that is called the focal point. You'll also just hear it called the focus. I'll try to go with focal point for you. We abbreviate it with an F. When you actually have to measure that, the distance from the mirror to the focal point is called the focal length. And then we're going to see two types of images. They're going to be real and virtual. A real image and a virtual image. A real image is when actual light rays cross in front of the mirror, and you can take that and you can project it someplace. And then a virtual image is one that appears like it's behind the mirror, and it cannot be projected. Like it can't turn into a hologram. Only real images can. This is going to drive people crazy. An example of this, when I take a mirror, or anytime you're out in the sun, when you have something reflective, if you have that catch the sunlight, and you can see how the light is striking here and bouncing off. You cannot see it at home, but I am projecting those light rays up onto the ceiling, and it actually, you can see the words that are here. I can project them to the ceiling. So a real image is going to be one that can be projected someplace else. It makes light go like that. A virtual image will not be able to do that, and it'll end up looking like it's drawn behind the mirror when we start doing our diagrams. Okay? Alright, a concave mirror. This is when the mirror surface caves inward. So in our drawing, what I have here is a concave mirror. The mirror surface caves inward, and that is what I have with this big mirror right here as well. So the mirrored surface actually kind of goes like that. If you don't have a mirror at home that's curved, that is okay. You can also use a spoon. The inside of a spoon is a concave mirror. All right, so at home, I'm going to have you do this, and I will do it with this big mirror. It worked when I set it up, but we'll see how well you can see at home. But what you're going to do is you are going to look into a concave mirror. When you are far away in a concave mirror, the object is upside down. Upside down. The fancy word for that is inverted. So I'm going to flash this mirror at the camera. You're going to be able to see the back of the room, and what you should see is that the back of the room is upside down because this mirror is far away from that object. Alright, so we've got an upside down image. If you can't see well, then you just go into a spoon. As I look into the inside of the spoon, my whole body is upside down. Alright, so how do things look in a concave mirror? They are inverted, which just means upside down. All right, as you pull it closer to yourself, as I pull my spoon closer, I get to a point right about here, and all of a sudden it gets really, really blurry. There's nothing that I can see at all. There's no image. There's just flashes of light. What I have done is I have found the focal point. At the focal point, you know you found it because everything gets blurry. There is no image that can be seen. But if you keep going a little bit closer, it's a little harder in a spoon, but I can see my eye. I'm going to pull this towards you here for a second so you can see that. What you are going to see is that up close, it flips right side up again, upright, and it gets bigger. It kind of magnifies it a little bit. All right, so as I come towards you, what you're going to see is far away, object is upside down. As it gets closer to the camera, what you're going to end up seeing is when I get past the focal point and get really close, it's going to flip to actually show you my phone right side up. All right, so when an object is up close, it will be larger and upright. All right, so our next piece, we are going to actually predict what we see in a mirror. We're going to be able to predict and measure it all out based on how far away it is from the surface of the mirror. All right, for this, you're going to want two colors. You can use a pencil and a pen, a pencil and a colored pencil, anything that you can kind of see the difference. I'm going to go red and blue for all of my different ones. Light ray number 1 is always going to be red. Light ray number 2 is always going to be blue. All right, concave, when I have something super far away, we already saw that it is going to be upside down, and it's going to end up kind of showing up being smaller. Excuse me, but we're going to actually be able to predict what should happen when that happens. So what I have here, principal axis, that dashed line, I need a drink, sorry. And right here, I have a curved mirror that is concave. I have shaped it so when light hits it, it's going to bounce off through the focal point right here. That's what the F is. And then my starting object is over here on the left side. That's the arrow. All right, your first light ray, pick whatever color you're going to stick with for light ray number 1. Your first light ray, please use your straight edge. You are going to draw a straight line from the top of the arrow all the way to the surface of the mirror. In class, I will give you a protractor for your straight line. You'll just lay it on your paper. You'll draw your straight line. You're going to have to deal with me. They're going to be a little bit off when I use my iPad for this. Okay, when the light ray hits the surface of the mirror, it bounces off. It always, because of the shape of the mirror, bounces off through the focal point. So it hits the mirror, bounces off through the focal point. And away it goes. All right, so light ray number 1, I have in red. it will go from the top of the object looking into the mirror, it will go a straight line until you hit the surface of the mirror. You'll then shift your straight edge and it'll bounce off through the focal point. Your second light ray, I'm going to go in blue. Your second light ray will do pretty much the opposite. It is going to always start at the top of the object arrow, but this time it is going to go through the focal point on the way to the mirror, and then it's going to bounce back straight. All right, so setting up your straight edge, you're going to set it up from here. It's going to go through there until you get to the surface of the mirror. And then when it hits the surface of the mirror, it's going to bounce back straight back. And I just put little arrowheads on it so you know which direction the light ray is going. All right, what we are looking for is the place that the two objects meet, or the two light rays meet, that is not the focal point. So we sent both of them through the focal point, but they end up bouncing back and meeting right here. That right there is going to predict what happens, what we're going to see in the mirror. Notice, this is the center point. This is below the mirror, which means it is going to be upside down. So when I have something far away in a concave mirror, it looks upside down. Notice it's also going to be smaller than it started. So here's the starting object. I'm going to go at a different color. Here's my starting arrow. That's how big it was looking into the mirror. Here's my next one. It's littler than it is right here. So what I see in the mirror is going to appear smaller than it actually is. And this is going to be what we see is a real image. It is in front of the mirror, which means I can take a mirror right here and I can actually take that image and project it someplace else, like I did up onto the, if you're in class, you'll see it up on the ceiling. All right, so light ray number 1 in red, straight until you hit the surface of the mirror and then bounces off through the focal point. Light ray number 2 in blue, it lines up through the focal point on your way to the mirror and then bounces back straight. Where they intersect at the place, not the focal point, where they intersect the bounce back lines, that is going to predict what you see in the mirror. You're going to see something that is upside down, smaller than the original item, and it's in front of the mirror, so it's a real image. All right, then remember we moved it closer to us until it got all blurry. That was because we were at the focal point, right? So now we're going to draw something that is going to look like it's at the focal point. Once again, start off the same way. I have my red line, straight line until I hit the surface of the mirror. Please use your straight edge. Straight line until I hit the surface of the mirror. It then bounces back through the focal point, like that. Right? So same as I started off before, I'm just closer. So straight line until I hit the surface of the mirror, bounces through the focal point. Light ray number 2, back to my blue. This time, I have to start, once again, always start at the top of your arrow, but it needs to go through the focal point. Notice, if you go through the focal point, that's straight down. That light ray is never going to hit the mirror. If the light ray doesn't hit the mirror, it doesn't bounce back, it doesn't make an image, the light rays can intersect, and what you have is something that is really blurry, and you get no image. And that is why it got blurry when we found the focal point of your spoon or a concave mirror. All right, and finally, our third type. What happens when I move it really close to my face? Okay, what I found there was it made it bigger and it flipped it upright. Okay, this is going to be because we're going to have to extend our lines behind the mirror in order to get this to work. All right, so back to color number 1. You're going to draw a straight line until you hit the surface of the mirror. It is then going to bounce back through the focal point. All right, straight to the surface of the mirror, through the focal point. Extend that line behind the mirror as well, the bounced off line. So straight to the surface of the mirror, through the focal point, extend it both in front and behind the mirror. All right, light ray number 2 in blue. This time, we need to be at the top of the arrow. It needs to go through the focal point. It has to meet both of those on the way to the mirror. So the light ray is going to start at the focal point, hit the top of the arrow until you hit the surface of the mirror. Like that. And then, through the focal point, it then bounces back straight, parallel with the principal axis. Bounce back straight. And once again, I'm going to extend that bounce back line. All right, so when the lines don't intersect in front of the mirror, extend them behind. All right, this line and this line are never going to meet. They keep going in an opposite direction. So we then had to extend them behind the mirror. They intersect back here. Right here is where they meet. Okay, that is what I'm going to see in the mirror. I am going to see something. It is above the principal axis, so it is upright. It is larger. This arrow, what I see in the mirror, is larger than what's looking in the original object looking into the mirror, which means it's going to magnify it bigger. It's going to make it look, it's like a makeup mirror. It looks really, really big. Okay, and this is going to be what we call a virtual image because it's behind the mirror. We can't put anything back there to project. There's not actually light going behind the mirror. We just have to draw it like it does. All right, so quick recap. First light ray goes straight to the surface of the mirror, bounces through the focal point. Second light ray goes through the focal point on the way to the mirror, bounces back straight. We look for where they intersect. If you are far away from the mirror, it will be upside down and smaller. If you are at the focal point, you can't get an image because one of the light rays just never meets the mirror. And when we have an object that's really, really close, then we have to, our lines would never meet. We have to extend them behind the mirror. We end up with a larger, magnified, bigger object in our mirror that is upright. And this is what's called virtual because it's behind the mirror. Okay, looking at this, strictly for mirrors, the variables for the mirror. Focal length, this one makes sense. It is an F. The object distance, so the starting object, the distance to the mirror, how far away it is from the mirror, this is going to be P. Don't know why, it just is. The image distance, how far away the image appears from the mirror, is Q. Once again, no idea. But then the other ones, high and low, these ones make sense. The height of the object, so the starting object looking into the mirror, is going to be HO. Height of the object, HO, and then height of the image is going to be HI. Sign conventions. When the image shows up, when they intersect in front of the mirror, you're going to have a positive distance. When it shows up behind the mirror, you're going to have it be negative. When an object is upright, the height is going to be a positive number, and when the image appears upside down, it is going to be a negative number. All right, we are going to take all of this information and we are going to start setting up a concave mirror diagram. All right, so for here, you need some type of measuring device, a protractor or a ruler. You are going to start, you are going to lay out your protractor. We are going to draw a scale ray diagram for an object that's 1 centimeter tall. That is the height of the object. And it is located 5 centimeters from a concave mirror. That's P, the object looking into the mirror, how far away it is. And it has a focal length of 2, that's going to be F. All right, I have to measure out those 3 things before I can draw my lines. Okay, first thing I'm going to do it on my iPad, obviously, but I'm going to show you up here. The protractor, the centimeters are on the inside right here, the inside of the curve. It starts with 0, 1, 2, up to 10, and then there's dashes in between. Each of the lines in between would be 5, so you'd have 1.5, 2.5, and so forth, okay? All right, everything is in centimeters. So first thing that I do is I get the starting object and how high the arrow should be. So you place your protractor here, you measure it to be 5 centimeters in front, that's to the left of the mirror. So I place this at 5 centimeters. I'm gonna put it on my iPad and then I'm gonna notch it so that I have it. This, I measured it to be 5 centimeters away. Right? I want the starting object to be 1 centimeter tall. That means my arrow to start with is going to be 1 centimeter tall. So I'm going to lay this once again on my iPad and I'm going to measure it to be 1 centimeter tall. Just measuring the height of it. And then the last thing I need to mark off the focal point. It needs to be 2 centimeters in front. So once again, I'm going to use my protractor on my iPad. You're doing it on your paper. I'm going to measure 2 centimeters right there. And then, if I can get it off, I'm going to label that F. All right, you have to have those 3 things measured out before you can run your lines. Okay, line 1 is red. Okay, I'm going to run a straight line. Use your straight edge, please. Straight line until you hit the surface of the mirror. It then bounces back through the focal point. Second light ray goes through the focal point on the way to the mirror and then bounces back straight. All right, so straight line through the focal point on the way to the mirror, and then it bounces back straight or parallel with the principal axis. Not a great line, but you can hopefully see. All right, what we are looking for is where they intersect, not the focal point. So this bounce back line intersects with this bounce back line right here. That's the intersection point of the 2 lines. I'm going to turn that into an arrow just so I can see it a little bit easier. Other people just draw a dot so you know where to measure to. All right, there are 2 things that you're going to measure. Q, the distance of your intersection point back to the surface of the mirror. So wherever it intersected, you go up to the principal axis, the dashed line, and you're going to measure the distance all the way back to the mirror. I'm going to lay this on here. Mine is about 3.2. Mathematically, perfect would be about 3.5. I would take anywhere between about 3 to 4, especially on your first drawing. Hopefully you fell somewhere in there, about ½ centimeter on either side. The other thing that you're going to measure, so that was Q. The other thing that you're going to measure is the height of the arrow. So how tall from this dashed line down to the intersection point, how many centimeters is that? So I'm going to lay mine on there. Mine was about 0.8. Mathematically, it is 0.7. But once again, I would take a range. I'm looking for something at about 0.3 to 1, kind of in that range, a little less than 0.7 and a little more than 0.7. And because it's pointing downward, you just have to remember it's upside down, so you can put a negative sign in front of it. All right, so those are going to be the things that you're going to measure. You're going to measure out how far away your starting object is, its height, and then a focal point. You're going to run your lines, see where it intersects. HI, height of the image, is how high is this arrow, and Q is the total distance back to the surface of the mirror. You'll measure those things. I'll have the correct answers on the page. You'll hope that you get close. The last thing is it real or is it virtual? If it ends up in front of the mirror, it's going to be real. If it ends up behind the mirror, it's going to be virtual. All of this is in front of the mirror, so it is a real image. Okay, now practice problem 2 and 3 are going to be your homework. Finishing off 1 and then working through 2 and 3 are going to be your assignment for tomorrow. So, thank you.